All right, let's talk about the silent killer for APIs. It's this sneaky vulnerability that I can almost guarantee exists in your application right now. See, it's not about whether a user can log in, that's the easy part. It's all about what they can do after they're in. And that's where we're going today, deep into API authorization.
So let me ask you a question, and I want you to be honest. Is your API, right now, secretly leaking user data? It's a scary thought, right? Because you're probably thinking, no way, all my functional tests are passing. Well, I'm here to tell you that might not be enough.
Yeah, the hard truth is that you can have a sea of green check marks. All your happy paths can be working perfectly. But underneath the surface, the biggest security holes can be just wide open. These are exactly the kind of flaws that standard tests fly right past. But today, we're going to learn how to hunt them down and slam that door shut.
Okay, so to really get a handle on this threat, we've got to break down two core ideas. And honestly, even seasoned engineers get these two mixed up all the time.
All right, think of it like this. You're at the airport. Authentication is your passport. It proves who you are. The security agent looks at it, scans it, and says, yep, you're a valid traveler. Welcome. But here's the thing. Just because you're inside the airport doesn't mean you can just wander onto any plane, right? Of course not. That's where authorization comes in. That's your boarding pass. It proves what you're allowed to do, like board this specific flight, at this specific gate, and sit in this specific seat.
And this analogy leads us straight to the single biggest API security risk out there, according to OWASP. It's called BOLA, or Broken Object Level Authorization. Now, in our airport world, BOLA is like an attacker taking their economy boarding pass, scratching out their seat number, and writing in 1A. They're trying to sneak into first class. In the API world, it's the same idea. An attacker uses their own valid token, but they just change a number in the URL, like a user ID, to try and grab someone else's data. It is terrifyingly simple, and you'd be shocked how often it works.
So you might be thinking, okay, I get it, but isn't this, a job for the security team? And look, it's easy to think that way. But if you do, you are missing out on one of the biggest opportunities you have to level up your entire career.
I mean, sure, on a high level, this is all about preventing those huge company-killing data breaches. It's about compliance, it's about trust, but let's be real for a second. For you, for your career, this is the stuff that separates a good automation engineer from a great one. You become the final line of defense. You're the one catching the critical flaws that developers who are laser-focused on features almost always miss.
And just to be absolutely crystal clear about the risk here, the official definition puts it perfectly. It says authorization flaws allow legitimate users to access data or functions beyond their defined permissions. The key word there is legitimate users. We're not talking about some random hacker from across the world. We're talking about authenticated users, people already inside your system, doing things they should never be allowed to do.
Okay, enough with the doom and gloom. Let's talk about how we fight back. Let's actually build our automated defense. And trust me on this, it is way simpler than you probably think.
We're going to follow a simple 4-step game plan. First, we need to define our test personas, our actors on the stage. Think user A and user B. Second, we need their digital keys, their authentication tokens. Once we have those, we launch a two-pronged attack. We'll test role-based access first, and then we go after the big one, object-level access.
All right, first up is RBAC. That's role-based access control. The question we're trying to answer is super simple. Can a user with low privileges, say a guest role, call an endpoint that should be locked down for admins only? Let's find out.
So, the test logic here is really straightforward. You can see it in the code. Given, we grab a token for a low-privileged guest user. When we try to use that exact token to hit an admin-only endpoint, like /admin/audit logs, then what do we expect? We expect the system to stop us in our tracks. But, and this is the most important part, we're not just looking for any old error, we're looking for one very specific, very beautiful number.
That number is 403. Seriously, burn this number into your brain. In the world of authorization testing, 403 forbidden is your new best friend. It's the ultimate sign that your security is working exactly as it should.
So what does a 403 forbidden actually mean? It means the server saw your passport. It authenticated you. It knows exactly who you are, but then it looked at your boarding pass and said, sorry, buddy, you've got an economy ticket. The first-class lounge is not for you. You are authenticated, but you are not authorized. Total access denied.
Okay, so checking roles is the warm-up act. Now it's time for the main event. We're going after the big one, the vulnerability that is #1 on the OWASP API security list. It's time to test for BOLA.
Here it is, the classic BOLA attack in code. It's so simple, it's scary. Given we're logged in as user A, and we have user A's valid token. When we try to get some data, like an order history, but in the URL we sneakily swap in the account ID for user B, then what happens? A secure system has to be smart enough to look at the token, see where user A and say, whoa, hold on, that's not your data. And how does it say that? By slamming the door with that beautiful 403 forbidden.
Okay, now that you have the playbook, let's talk about the landmines. These are the common traps that almost everyone falls into when they first start. Think of these as the pro tips that'll help you skip the beginner mistakes.
All right, here are the rookie mistakes that everyone makes. First, and this is a big one, they just check for any failure. Listen, a 500 server error isn't a security win. That's just another bug. A 403 forbidden is a security feature. You have to assert for that specific code. Second big mistake, only testing with a super powerful admin user. That tells you nothing. Of course the admin can do everything. You need to test as a normal, everyday user. And finally, please don't hard-code resource IDs. You need to create your test users and their data dynamically for these tests to be meaningful. You're not here to prove the happy path works. You're here to prove the system can't be broken.
All right, we have covered a ton of ground. We've talked about the threat, the core concepts of authentication versus authorization, and the exact strategy to automate your defense. Let's wrap this up and bring it all home.
So if you only remember 3 things from this, make it these. 1, authentication is who you are. Authorization is what you can do, the passport and the boarding pass. 2, test for BOLA by using user A's token to try and steal user B's data. 3, test for RBAC by using a guest token to hit an admin function. And for both of those negative tests, what are you looking for? You're always asserting for a 403 forbidden.
And I'm not kidding about this. If you actually go and automate these checks in your pipeline, you will immediately launch yourself ahead of probably 80% of other QA engineers out there. This isn't just some nice-to-have skill. This is a legitimate career maker.
But wait, we're not done yet. All of these tests rely on having valid auth tokens, right? And getting those manually is a total pain. So, in our next explainer, we're going to tackle exactly that, how to fully automate token generation using standard OAuth 2.0 flows, so you never have to waste a single second doing it by hand ever again. You're not going to want to miss that one. I'll see you then.